Alright, in this chapter we're going to go through adding an analog front end, and for that I'm going to copy a project called PlainDAQ. So this is the best analog front end I've found so far, so we're just going to copy this. Input goes into a buffer, gets divided, paired with the non-inverting input, sent into some sort of fancy op amp, and then into an ADC with an SPI peripheral. Alright, so that's what we're going to do. Alright, we have our code here from the last chapter, so we'll add to it. We're going to say def analog front end, and we won't take anything for now. So I guess we know, well, we can say, we know we're going to do SPI in, so we have to send in those pins. SPI, SDO, SPI, SCLK, and then the chip select. And then we'll probably need our standard 3.3 volts and ground. Alright, so we'll pass in those nets. We'll start out with a terminal block. So I've already pre-selected these parts, so I'm just going to copy and paste them in. So we got our terminal block, just a generic connector, 5mm through hole. Okay, so that'll be where the analog plus and analog minus come in through. And then for the buffer stage, we'll use a op amp. So we're just going to use the Spice Simulation Library op amp, and then the footprint will be SOT236. So that should be hopefully fairly common. Alright, so now we need to know what the pins are of these parts. So we're going to create a little function. We'll call it print pins, and it's just going to take in a part and it's going to print all of its pins. So that way, as we're developing, we could just do this through the terminal too, but for now we'll do it this way. Alright, so we're going to print out all the pins of the buffer so we know how to connect it. And then here we're going to call the analog front end, and then we're going to pass it in some ESP32 pins. So actually let's use that first to see which ESP32 pins we should use. Okay. So we should see like an SDO. Here we go, an SDO, SCK, and I guess we'll just use SDI. So we'll use these three pins, 20, 21, and 22. But we want to use their names, which will be both of these names right here. So we'll pass in the analog front end. What's first? SDO, then the clock, then the chip select. Okay, so ESP32. Okay, so DO is going to be first, and then we already have clock, so we need the chip select. So these pins could change in the future, but it's pretty easy to change them. Okay, so now we should be able to, we'll turn that off so we're not spamming, and now we'll print out the pins of the op amp so we know how to connect it. Alright. Should be going, okay, there we go. Okay, so we see pin 1 is plus, minus output V plus V minus. Okay, so we will hook up the plus to, let's see, we're going to do buffer plus to terminal block 1. And then the minus is going to be, just looking back at the schematic, the minus is going to be the output of this op amp. So connect the minus pin to the output pin. Okay, so it's going to be buffer minus goes to buffer output. Okay, and then I got the rest of these, so I'm just going to copy and paste them. Alright. Cool, that's all the buffer. And now, after that we have a voltage divider. So we will make one of the resistors first, and then we need to make another op amp that this resistor will feed into. We'll call that the summer. And then we gotta connect the summer. And now we can connect the buffer output through the resistor to match this other resistor up here. So make it from the summer plus to the buffer output, which is this circuit right here, right? So R5 is what we just made. And that other resistor was this R7, so now we're going to make R8. So copy and paste these. Okay. And now we need Adc Driver, this thing right here, 8813, and all the peripheral circuitry, so I'm not going to hop back and forth, I'll just describe it. So we have a voltage divider, capacitor, another voltage divider, the output into an RC circuit. Okay. So we had to make the ADC though, because that symbol wasn't available. So I'll show you real quick how I made, you can make a symbol library, just make sure that it's a new symbol library, just make sure it's in the path, the KiCad path, the default one. So that is in preferences, configure paths, so mine is in, here I'll turn this on. Mine is in user share KiCad symbols, so this is the path that SKiDL is going to look for the symbol library. So just make it in there. Okay. And now add in all those resistors and the capacitor. And for the ADC, we will the ADC part, we'll use the ADS 7049. So here's the ADC, and now we'll make all those RC circuits. which are around 58 megahertz if you calculate it out. And now finally we can attach all of the SPI peripheral to the ADC. Alright, so we added all our analog front end. And another thing now with the analog front end is that we care about tolerances. So we can add in tolerances to our, we already have tolerances called out, so they're 5%ers. So with the analog front end, perhaps we can say, tolerance equals 0.1%. Right, and we'll add that on all of these, all these parts here, just to make sure we're using correct parts, because these are going to be supposed to be a high precision measurement. So okay, so we added the analog front end. We went through the print pins function that helped us look at the pins of a part. And then we went through how to add the custom library, as well as now we're using tolerances for our RC, or our R's and our C's. So, alright, that's all for this lesson.